All right, let's talk about electric current. Current is related to the voltage that produces it and the resistance that opposes it. We did something in class where we were all charges and we were walking through the path. And depending on the speed that we were, was the amount of the current. Voltage produces a flow of charge or current within a conductor. The flow is slowed down by the resistance it encounters. So when charges go through a battery and they receive some extra energy, then they're going to go and give that energy to other things. Those other things that they give that energy to are called resistors. And that energy is given off in the form of heat, light, sound, whatever it is the resistor does. So if we have a radio plugged in, then we give that energy to the radio to turn on and receive radio waves, or to turn on and produce the music. If it's a light, when you turn on the light, it changes the energy into thermal energy, which then gives off light energy. The rate that energy is used is power. So the rate that energy is transferred from the electric current is the power. When the ends of an electrical conductor are at different electric potentials, charge flows from one end to the other. That's what happens with your batteries. The charges flow from the positive terminal to the negative terminal because the positive terminal has a greater potential difference than the lower potential difference. And we're going to look at more of that to see what potential difference is and all of that as we go on. So heat flows through a conductor when temperature difference exists. Heat flows from a higher temperature to a lower temperature. Think about a coffee cup with hot coffee in it, or a paper cup with ice cream inside. That paper cup is going to get really cold, right? Because there's that difference of temperature. So you lose heat from your fingers to the ice cream. And what that does is it heats up the ice cream and it causes it to melt. It also causes the temperature in your hands to be a lot cooler. So you're able to feel the coldness of that a lot easier. Heat flows from higher to lower temperatures. When temperature is at equilibrium, the flow of heat ceases. Charge flows in the same way. Charge goes when there's a potential difference or a difference in potential between the ends of a conductor. The flow continues until both ends reach the same potential. When there's no potential difference, there's no longer a flow of charge through the conductor. To attain a sustained flow of charge in a conductor, one end has to be at a higher potential than the other. The situation is analogous to water. I like to picture water when I talk about electricity just because water and electricity go really nice together. And what I mean by that is not that you should mix the two, but if you think about water, which we can see and we can visualize, we have experience with it, we've seen water come out of the faucets, we know the basic idea of what water does. So electricity, which is a lot more abstract and we can't really picture the charges going through as easily, using electricity as an analogy is going to help. Electrons in a wire are like water in a pipe. Whenever a little water enters one end, almost immediately the same amount of water exits the other end. Water flows from high pressure to low pressure, just like temperature flows from high temperature to low temperature. Heat flows from high temperature to low temperature. Water flows from high pressure to low pressure. The flow is going to stop when the difference in pressure no longer exists. Water will continue to flow because a difference in pressure is maintained with a pump in part B. So what this pump will do is this pump is going to give the water some extra energy to get it back up to the top so it gets into the big well, which will then flow into the small well. And then this will just continuously go on forever and ever and ever, as long as this top well keeps getting full. So a quick concept check. What happens when the ends of a conductor are at different electric potential? You should be able to answer that